Okay, now we've differentiated e to the x, we're going to go on and differentiate log x to the base e. Now, so again, we're going to let y equal log x to the base e. Now then we're going to use this, we're going to convert this back into the exponential form, right? Remember how it goes, that this will be e to the, I'll just take this across here, I've rearranged it a little bit so it's a bit hard for you to see. So this becomes e to the y, okay, equals x. But what I've done is just swap these around, because I'm going to differentiate this with respect to the variable y. So this time I'm going to get dx dy, well obviously it's going to be e to the y, right? Now we can then swap these around, put the inverse, and say dy dx equals 1 on e to the y. But e to the y is equal to x, so dy dx equals 1 on x. So the derivative of the log x is 1 on x. Right, now, if you looked at, say, the graph of this, right, we take the graph of the log function, which looks like this, then we're saying it's quite interesting that the gradients of all these, in fact, when we did them, would come out to being, in fact, the gradient here, see it's positive, a very steep positive curve, very steep positive, okay, and then it's going to get flatter as it goes, but never ever zero. So that maps beautifully onto the hyperbola. So it's quite interesting, isn't it? The log function, when you find the derivative of it, maps onto the hyperbola.